The ground beneath you feels perfectly still. It is not. You are moving through space at several speeds at once. You feel none of them. Consider 3 numbers that refuse to agree. At the equator, the ground itself turns at about 1,670 kilometers per hour. Earth sweeps around the sun at more than 100,000 kilometers per hour. The sun carries every planet around the galaxy at roughly 800,000 kilometers per hour. Each of those speeds is real, yet none is the one true speed. Each is measured against a different reference point. Physics offers no fixed stage in the universe. That absence of a fixed stage is the real puzzle. This episode climbs through 4 layers of motion. It begins with the spin under your feet. It rises to Earth's orbit, then the sun's path around the galaxy. Finally, it reaches the galaxy itself, racing against the oldest light in the cosmos. If steady, evidence-driven space science helps you rest, consider subscribing to Gravity of Sleep. Now the story begins with the simplest motion of all. Earth turns once on its axis relative to the distant stars in 23 hours, 56 minutes, and 4 seconds. Astronomers call this a sidereal day. Notice that it is not the 24-hour day on your clock. Your ordinary day is measured against the sun. The sidereal day is measured against the stars far beyond it. As Earth spins, it also creeps forward along its orbit, so it must turn a little extra each day to bring the sun back overhead. That small extra turn is why the star day runs about 4 minutes shorter. The distinction matters here. True rotation is best measured against the fixed stars. Now picture the planet as a spinning globe. Its widest point is the equator. There the surface must travel the greatest distance in a single turn. Earth's circumference at the equator is about 24,901 miles. In metric terms, that is roughly 40,075 kilometers. Every point on the equator covers that full loop each day. The reason the equator moves fastest is pure geometry. Every part of the planet completes one turn in the same time. But the equator has the largest circle to travel. A point near the poles traces only a tiny ring. Same duration, far greater distance, far greater speed. So divide that distance by the length of one rotation. The ground at the equator moves at about 1,670 kilometers per hour. In more familiar units, that is close to 1,040 miles per hour. You are sitting on a surface faster than most passenger jets, yet nothing in your body registers the motion. This is not a rough estimate. The radio astronomer Alastair Gunn of the Jodrell Bank Centre for Astrophysics gives the same figure. The number also follows directly from the planet's size and spin. 2 independent paths reach 1,670 kilometers per hour. You feel nothing because you move with the surface. The air, the oceans, and your body all turn together. There is no wind of rotation to push against. Motion at a steady speed leaves no sensation. only a change in speed or direction can be felt. This is your first meeting with the real puzzle of the episode. Speed only has meaning against something else. You measure the equator's speed against the center of the Earth. Against the chair beneath you, your speed is 0. Both statements are true at once. There is no hidden master clock that settles which one counts. But this spin speed is not the same everywhere. It depends on where you stand on the globe. The equator sweeps the widest circle, so it moves fastest. Move toward either pole and the circle shrinks. The speed falls with the cosine of your latitude. Consider a city well north of the equator. New York sits near 40.7 degrees north. There the ground turns at only about 1,260 kilometers per hour. That is close to 785 miles per hour. The same planet, the same single rotation, yet a slower local speed. Stand exactly at a pole and your spin speed falls near 0. You would simply turn in place once a day. So even the first and simplest layer of motion refuses to give one clean number. Your spin speed already depends on your position on the globe, and this spin is only the smallest of the 4 layers. The whole spinning planet is itself being flung around the sun. Earth does not hold still while it turns. It races along a vast loop around the sun. NASA measures one full orbit relative to the stars at 365 days, 6 hours and 9 minutes. That is the true length of Earth's year against the distant stars. These orbital numbers come from precise measurement, not estimation. The length of the year is known to the minute. The changing distance to the sun is measured with great care. From those measurements, the speed follows directly. Along that loop, Earth's speed is enormous. It moves at between 29.29 and 30.29 kilometers per second. Notice that this is a range, not a single value. The speed changes across the year. That variation reveals something important about the shape of the orbit. Earth's orbit is not a perfect circle, it is a slightly stretched ellipse. So the planet is not always the same distance from the sun. When it swings closer, it speeds up. When it drifts farther, it slows down. The closest approach is called perihelion. In the year 2026, Earth reached perihelion on January 3rd. Its distance from the Sun was about 147 million kilometers. At that point, Earth moved at roughly 30.29 kilometers per second. In meters, that is about 30,290 per second. This is the fastest Earth ever travels along its orbit. And it happens in the depth of the northern winter. Half a year later, Earth reaches its farthest point. This is called aphelion, and it falls in early July. There the planet sits about 152 million kilometers from the Sun. At that greater distance it slows down. Earth moves roughly 970 meters per second slower than at perihelion. The same planet, the same orbit, 2 different speeds. The gap between them is small against the total, yet it is measured, predicted, and confirmed year after year. Translated into more familiar units, the numbers grow dramatic. At its fastest, Earth sweeps around the Sun near 109,000 kilometers per hour. That is roughly 67,700 miles per hour. This second layer dwarfs the spin beneath your feet, and still, you feel none of it. The orbital motion carries the entire planet as one. The Sun does not rush past your window. The stars do not streak overhead within an hour. The scale is simply too large for your senses to catch. Only careful measurement across months reveals the truth. So the second layer, like the first, hides a moving target. Your spin speed depends on your latitude. Your orbital speed depends on the season. Neither offers a single honest number for how fast you move. And these two speeds do not even point the same way. The spin carries you east with the surface. The orbit carries the whole planet along a curve around the Sun. To combine them, you would have to track two different motions in two different directions at every instant. Now hold both motions in mind together. You are turning with the surface at over 1,000 kilometers per hour. You are riding the planet around the Sun at more than 100,000 kilometers per hour. These are only the two innermost layers. Above them waits a motion far larger and far slower to reveal itself. The Sun itself is not standing still at the center of things. It is carrying Earth and every other planet on an immense journey around the Milky Way. That journey follows a vast circle around the heart of the galaxy. At the center lies a crowded core of ancient stars. A supermassive black hole rules that region with enormous gravity. The Sun does not fall inward toward it. Instead, it sweeps around that center on a long, patient orbit. Everything you know rides along inside that curve. The planets travel together. The asteroids and the distant comets travel with them. All of it moves as one enormous, silent procession. And the speed of this motion dwarfs everything the story has measured so far. For many years, astronomers relied on a single agreed number. The International Astronomical Union set a standard value near 220 kilometers every second. That figure does not describe the Sun alone. It describes a quiet, imaginary point in our neighborhood. Astronomers call it the local standard of rest. Think of it as the average motion of nearby stars. They all circle the galaxy together in a broad, sweeping current. The Sun rides close to that average, with a small drift of its own. So this standard value became the working answer for the Sun's galactic speed. 220 kilometers per second is difficult to feel as a number. So consider what it means at a human scale. In a single second, that motion carries you 220 kilometers. In the time it takes to read one calm sentence, you have crossed a great distance. And unlike the spin and the orbit, this motion barely changes from night to night. It is steady, vast, and almost impossibly smooth. You are being carried through the galaxy, and nothing in your body reports it. But the standard value was always an approximation. It rested on older surveys and simpler models of the galaxy. Newer instruments promised something far more precise. And in recent years, one measurement sharpened the picture considerably. It came from a study published in 2017. The lead researcher was Jason Hunt, an astronomer at the Dunlap Institute in Toronto. His team did not measure the sun in isolation. Instead, they studied the motions of the stars around it. They combined data from two great surveys of the sky. One was the Gaia mission, a spacecraft built to map the galaxy with extraordinary care. The other was a ground survey called RAVE, which measured stellar velocities in bulk. Together, these gave the team the movements of more than 200,000 stars. That is an immense catalogue of motion to hold in one analysis. And within it, the researchers looked for something subtle. They searched for stars that seemed to be missing. This is a strange and elegant idea, so let it settle for a moment. In a smoothly turning galaxy, stars should appear at every speed around us. Some should trail slightly behind the sun, some should run slightly ahead of it, but the survey revealed a quiet gap in that pattern. Certain stars that should have been present were simply not there. Their absence was not an error. It was a clue about our own motion. By measuring exactly where that gap fell, the team could locate the sun's true speed. The missing stars acted like a marker against the flow of the galaxy. From that marker, the researchers refined the sun's galactic velocity. Their answer came out near 240 kilometers per second. That is a little faster than the older standard figure. The difference sounds small in words. Across the scale of the galaxy, it matters a great deal. The same analysis pinned down another crucial number. It measured how far the sun sits from the galactic center. That distance came out near 7.9 kiloparsecs. In more familiar units, that is about 26,000 light years. Light itself, the fastest thing in the universe, needs 26,000 years to cross it. And that distance is only the radius of our orbit around the center. The sun is not near the crowded core at all. It rides in a calmer outer district of the galaxy. This quiet position may be part of why life had time to arise here. Now bring these figures back to human units for a moment. 240 kilometers per second becomes an astonishing hourly speed. It works out to roughly 828,000 kilometers per hour. In imperial terms, that is about 514,000 miles per hour. Compare that to the orbital speed you met earlier. Earth races around the sun near 109,000 kilometers per hour. This galactic motion is many times faster still. Each layer of the story moves faster than the one beneath it. Yet even this tremendous speed produces an achingly slow journey. The galaxy is simply too large for haste. To complete a single loop around the center, the sun needs an enormous span of time. Astronomers estimate one full orbit at somewhere between 225 and 230 million years. They call that span a galactic year. It is the true year of the solar system. Our ordinary year measures one trip around the sun. A galactic year measures one trip around the entire galaxy. Let that immense clock reframe the history you know. When the sun last occupied this point in its orbit, the world looked nothing like today. The earliest dinosaurs were only beginning to appear on land. Whole ages of life have risen and vanished since then. Continents have drifted, collided, and rearranged the map of the planet. And in all that deep time, the Sun has completed only one loop. The human story occupies the faintest sliver of a single galactic year. Consider what that means for our own brief existence. Modern humans have walked the Earth for a few 100,000 years. Across an entire galactic orbit, that is a passing instant. Since the first cities were built, the Sun has barely moved along its path. We have never watched the solar system return to a familiar place in the galaxy. No civilization ever will within its own lifetime. We are travelers on a journey far longer than memory can reach. And still, this galactic motion is not the whole picture. The 240 kilometers per second describes the Sun's broad orbit, but layered on top of it is a smaller, more personal drift. The Sun does not simply follow the average current of nearby stars. It moves gently relative to them as well. Like a swimmer easing across a slow-moving river, it holds its own direction. This extra motion is small compared to the galactic orbit, yet it points somewhere specific and worth naming. That private drift measures about 13.4 kilometers per second. It is modest beside the great galactic sweep, but it carries the Sun steadily toward one region of the sky. Astronomers call the target the solar apex. It lies in the direction of the constellation Hercules. More precisely, it points near the bright star Vega, so even within our local swirl of stars, the Sun has a heading. Slowly, quietly, it is drifting toward Hercules across the ages. This smaller motion reveals something important about all these numbers. Each speed is measured against a different backdrop. The spin is measured against the Earth beneath your feet. The orbit is measured against the Sun. The galactic motion is measured against the center of the Milky Way. And this gentle drift is measured against the nearby stars themselves. Change the backdrop, and the number changes with it. There is no single frame that holds every motion at once. So the Sun carries the Earth on two galactic journeys at the same time. The great one circles the center at 240 kilometers per second. The small one drifts toward Hercules at 13.4 kilometers per second. Both are happening beneath the same still night sky, and both leave your body without the faintest sensation of movement. You feel anchored, while the Sun steers a course across the galaxy. It is worth pausing on how quietly all of this was learned. No one felt the Sun's galactic speed. No instrument was ever placed outside the galaxy to watch us pass. Instead, astronomers read the motion in the light of distant stars. They measured shifts in color, tiny changes in position, and gaps in the crowd. From those faint signals, they reconstructed our path around the galaxy. The stillness you feel was overturned by careful, patient observation. And yet, for all its size, this galactic motion still hides a target. 240 kilometers per second describes our speed around the center. It does not tell you how the whole galaxy itself is moving. The Milky Way is not fixed in the darkness like a landmark. It too is traveling through space, carrying the sun and everything within it. To find that motion, astronomers needed a backdrop larger than any star. They needed something that fills the entire sky at once. So the story now steps beyond the galaxy altogether. The layers so far have all lived inside the Milky Way. The spin belongs to the Earth. The orbit belongs to the solar system. The galactic sweep belongs to our neighborhood of stars. But the next motion belongs to the galaxy as a whole. To measure it, scientists had to find a truly universal reference. And remarkably, such a reference exists. It is the faint afterglow of the beginning of the universe itself. That afterglow has a name. Astronomers call it the cosmic microwave background. It is the oldest light in the universe. It was released when the cosmos was still young and hot, and it has been traveling toward us ever since. Today it arrives from every direction at once. It does not belong to any single star or galaxy. It belongs to the universe as a whole. And that is exactly what makes it so useful. It gives astronomers a backdrop that fills the entire sky. If we were perfectly still against this ancient light, it would look the same everywhere we looked. Its faint glow would carry the same temperature in every direction. But it does not. When scientists measured it with great care, they found a gentle imbalance. In one part of the sky, the light appeared very slightly warmer. In the opposite part, it appeared very slightly cooler. That small pattern is the fingerprint of motion. Movement crowds the light waves ahead of us and stretches the ones behind. What we rush toward looks warmer. What we leave behind looks cooler. From that warm and cool pattern, the answer emerged. The sun, and the whole solar system with it, is moving at roughly 370 kilometers per second against this ancient light. That is close to 1 1/3 million kilometers per hour. And it has a direction. We are drifting toward the constellation Leo. Every second carries us a little deeper into that region of sky. It is a motion no instrument on Earth could ever feel. Notice how strange this figure is. Around the galaxy, the sun travels at about 240 kilometers per second. Against the afterglow, it travels at about 370. These are not the same motion. They point in different directions and follow different rules. One is an orbit around the galactic center. The other is the combined drift of everything, measured against the birth light of the cosmos. The universe does not offer one speedometer. It offers many, and each tells a different truth. But this measurement hides something larger. The sun's speed against the afterglow is not the sun's alone. It carries the motion of the entire Milky Way inside it. When you measure yourself against the oldest light there is, you cannot separate your galaxy's journey from your own. So astronomers ask the next question. If we set aside the sun's orbit within the galaxy, how fast is the Milky Way itself moving? How quickly is our whole island of stars sweeping through the wider universe? The answer is more striking still. The Milky Way, together with its small family of neighboring galaxies, is moving at roughly 600 kilometers per second. One careful measurement placed the number near 627 kilometers per second. That is more than 2 million kilometers per hour. Our entire galaxy, with its hundreds of billions of stars, is being carried across space at that rate, and once again, the motion has a direction. It points toward the constellation Centaurus. This raised a difficult and obvious question. What could pull an entire galaxy that fast? A single star has almost no effect across such distances. Even a modest cluster of galaxies seems far too small. Something enormous had to be drawing the Milky Way and its companions along. Something with a gravitational reach spanning hundreds of millions of light years. Whatever it was, it lay in the direction of Centaurus. And for a long time, its true nature stayed hidden. Astronomers gave this unseen mass a fitting name. They called it the Great Attractor. It is a vast concentration of matter, thought to lie somewhere between 150 and 250 million light years away. Its gravity appears to be pulling our galaxy and thousands of others toward a shared region of the sky. For decades it stood as one of the great puzzles of cosmology. We could feel the pull in the flow of galaxies around us, yet the source of that pull was slow to reveal itself. As astronomers mapped the motion of galaxies more precisely, they found something they did not expect. The Great Attractor alone did not account for all the movement. The pull seemed to continue past it, towards something farther away and even larger. Behind the Great Attractor, at a much greater distance, lies one of the most massive structures we know. It is called the Shapley supercluster. It gathers an immense number of galaxies into a single overwhelming concentration of mass. The newer picture is humbling. Our local group may not simply be falling into the Great Attractor, it may be flowing past it, drawn onward toward the Shapley supercluster beyond. The Great Attractor, once imagined as our destination, may be only a waypoint. The deeper source of the pull could lie far further into the direction of Centaurus. We are riding a current across the cosmos, and we still cannot see the bottom of the river that carries us. This is the pattern that keeps returning in our story. Each answer uncovers a larger motion behind it. The spin of the Earth is real, but the Earth orbits the Sun. That orbit is real, but the Sun circles the galaxy. The galactic sweep is real, but the whole galaxy races toward Centaurus. And even that headlong rush seems to be part of something greater. Every reference frame we trusted turns out to be moving inside another. To make sense of all this flowing, astronomers needed a new kind of map. Not a chart of where galaxies sit, but a chart of where they are drifting. Instead of plotting positions, they traced motions. They followed the streams of galaxies, noting which way each one was being pulled. When they connected those flows, a hidden structure appeared. Regions where the currents ran together formed a single basin. Our galaxy, it turned out, belongs to one such basin. In the autumn of 2014, a team of astronomers gave that basin a name. Its edges were defined by the direction galaxies flow, like water finding its way toward a shared valley. The structure is enormous beyond easy comparison. It holds something like 100,000 galaxies. It spans roughly 400 million light years from side to side. Its total mass is thought to be around 100 quadrillion times the mass of our Sun. Our Milky Way sits near its outer edge, a single dot within an ocean. The astronomers who mapped it chose a name from the Hawaiian language. They called it Laniatea, meaning immense heaven. The name honors the Polynesian navigators who once crossed the vast Pacific by reading the stars. It was a fitting tribute. Those sailors found their way across a trackless ocean using the sky as a guide. Now the sky itself had been revealed as an ocean of its own, with our galaxy adrift inside it. Yet even this grand structure comes with a warning. Laniatea may not be a permanent home. Later studies suggest it might not be bound together by its own gravity at all. The expansion of the universe, driven by the force we call dark energy, may be stronger than whatever holds it. If that is true, then Laniatea is not a fixed continent. It is a temporary gathering, slowly being stretched apart. In the distant future, its galaxies may drift beyond one another's reach, carried away by the swelling of space itself. So consider where the layers have led us. You began by feeling perfectly still. Then came the spin of the Earth, roughly 1,700 kilometers an hour at the equator. Then the orbit around the Sun, tens of thousands of kilometers an hour. Then the long circle around the galaxy, hundreds of thousands. Then the galaxy's own rush towards Centaurus, faster than any of them. And finally the drift of a supercluster that may not even hold together. Each motion is real. Each was measured with patience and care. And no single one of them is the whole truth. This leads to a question that sounds simple, but is not. If we are spinning, and orbiting, and circling, and racing all at once, what is our real speed? Surely we could add every layer together and reach one final number, but nature refuses to cooperate. Each of these motions is measured against a different thing. The spin is measured against the center of the Earth. The orbit is measured against the Sun. The galactic sweep is measured against the center of the Milky Way. The last great motion is measured against the ancient afterglow of the beginning. These reference points are not fixed relative to one another. They move, they point in different directions, and those directions are always changing. Adding the numbers together would be like adding distances measured from 4 separate starting lines. The sum would carry no meaning. This is why scientists take such care never to quote a single total speed. There is no cosmic milepost that everything else stands still against. The closest thing we have to a universal figure is our motion against that ancient light, and even that is only the closest thing. It is not a final answer. So consider what that ancient light actually does for us. It fills the entire sky in every direction. It arrives from everywhere at once. It is the oldest thing any instrument has ever detected. This radiation was released long ago, when the young universe first turned clear. Before that moment, the cosmos was a dense fog. Light could not travel freely through it. Then the fog lifted, and that first free light began its long journey. It has been traveling ever since. It surrounds us now like a faint and even glow. If we were perfectly still, that glow would look the same in every direction. Its warmth would match on every side of the sky, but it does not match. One half of the sky reads slightly warmer, the opposite half reads slightly cooler. That small imbalance is not a flaw in the universe. It is a flaw in our stillness. We are moving into the light on one side. We are moving away from it on the other. Motion does this to light. When you move toward a source, its waves crowd together. The light shifts toward the warmer, bluer end. When you move away, the waves stretch out. The light shifts toward the cooler, redder end. The faster you move, the larger the difference. So the ancient glow becomes a speedometer. We read how warm the sky looks ahead of us. We compare it to how cool it looks behind. The size of that gap reveals our speed through the universe. When scientists perform that reading, a clear number emerges. Relative to this ancient light, the Sun and all its planets are moving at about 370 kilometers every second. In more familiar terms, that is over 1 million kilometers every hour. The direction points toward the constellation Leo. This is not the motion you learnt as a child. It is not the spin. It is not the orbit around the Sun. It is the sum of our deeper drift, read against the oldest light there is. Imagine that reading drawn as a single picture, a map of the whole sky, smoothed and complete, showing the warm side and the cool side at once. The two blend into one gentle pattern, one soft gradient across the heavens. That pattern has a name. Scientists call it the deep hole. It is the plainest evidence we have that our stillness is only local. We are not resting against the universe. We are sailing through it. But the Sun is only a passenger. It is carried by something far larger. The entire Milky Way is moving as well. When we measure the galaxy itself against that same ancient light, the number grows again. Our galaxy and its small family of neighbors are traveling at roughly 600 kilometers every second. One careful measurement placed the figure near 627 kilometers each second. That is more than 2 million kilometers every hour. The whole spiral, holding hundreds of billions of stars, moves together as one. The direction of that motion is not random. It points toward the southern constellation Centaurus. Something in that part of the sky is pulling us. For decades, astronomers could not see clearly what it was. Our own galaxy blocks the view. The crowded band of the Milky Way lies directly across that region. Stars and dust and gas hide whatever waits beyond. So the source of the pull was hidden behind the very thing it was pulling. They gave it a plain and honest name. They called it the Great Attractor. The Great Attractor is a vast concentration of mass. It lies somewhere between 150 and 250 million light years away. At that distance, it sits far beyond our galaxy. It sits far beyond our small local family. Yet its gravity still reaches across the gulf and takes hold of us. It draws the Milky Way and its neighbors toward it at that steady 600 kilometers each second. This is gravity acting over a distance almost too large to picture. and it acts on everything we know at once, without any of us feeling a thing. Here the story deepens once more. For a time the great attractor seemed to be the destination. It looked like the place at the bottom of the hill, the point our motion was falling toward. But newer study suggests the picture is not so simple. The great attractor may not be the true anchor of our fall. Beyond it, much farther away, lies something even more massive. It is a great gathering of galaxies called the Shapley supercluster, and its pull may be the deeper reason for our motion. If that is correct, then we are not simply falling into the great attractor. We may be flowing past it. We may be sweeping through that region on a much longer journey toward the far greater mass behind it. The nearer pull is real, but it may be only a waypoint. The true current runs deeper into the sky than we once believed. Our galaxy is riding a flow whose far end we are still trying to find. Now hold all of this together for a moment. The reason none of it touches your senses is quiet and simple. Your body does not feel speed. It feels a change in speed. A steady motion, however fast, produces no sensation at all. Think of a smooth flight at cruising height. The aircraft carries you at enormous speed, yet a cup of water on the tray sits perfectly still. There is no wind inside the cabin. There is no feeling of rushing forward. Only a change would announce itself. A sudden climb, a turn, a gentle drop. Steady travel feels exactly like rest. The Earth gives you the smoothest ride imaginable. Its spin never speeds up or slows within a human moment. Its orbit curves so gently that the change is beyond feeling. The sun's long path around the galaxy bends across millions of years. The galaxy's own rush holds steady across all of recorded history. Every one of these motions is almost perfectly even. And because they are even, they hide. Your inner ear finds nothing to report. The ground beneath you seems fixed and final. That is the quiet trick of the cosmos. It moves you constantly, and it moves you softly. It gives you no jolt to betray the journey. And so you sit, apparently still, in a room that seems anchored to a solid world. The window shows a steady sky. The floor holds firm. Nothing in the moment suggests a speed of any kind. There was once a hope buried inside all of this. Perhaps somewhere the universe holds a place of true rest. Perhaps one frame exists against which all motion could be honestly counted. The ancient light seemed for a while like a candidate. It fills all of space. It comes from the beginning of everything. Surely it might serve as the fixed wall the cosmos is measured against. But it is not a wall. It is simply light, spread evenly through a moving universe. We can measure our motion against it because everything shares it. That makes it useful. It does not make it still. Nothing in the sky is truly nailed in place. So the honest answer keeps its shape. There is no single speed that describes you. There is a spin. There is an orbit. There is a galactic sweep and a deeper cosmic flow beneath them all. Each of these is real. Each is measured against a different thing. And that ancient light gives us the widest, calmest ruler we own. Even it only tells us how we drift relative to the glow. It does not point to a final stillness, because no final stillness exists, and still the layers are not finished. We have followed the Earth, we have followed the Sun, we have followed the galaxy, we have measured them against nearby stars and against the oldest light. But the galaxy itself belongs to something larger. It sits inside a structure so vast that we only mapped it in full within the last generation. To see where all this motion truly belongs, we must pull back one more time. We must leave the single galaxy behind and look at the great web it is quietly stitched into. The Milky Way is not anchored to anything. It moves as a single body through the dark. And it does not travel alone. It belongs to a small family of galaxies held together by gravity. Astronomers call this family the local group. Our galaxy and the Great Spiral of Andromeda are its two largest members. When scientists measure the motion of that whole group against the oldest light, they find a speed larger than anything we have counted so far. The entire local group is sweeping through space at roughly 600 kilometers every second. Some careful readings place it a little higher. One survey of that ancient microwave glow measured the drift at close to 627 kilometers per second, give or take about 22. Set that against the clock of a highway, and the number stops feeling like physics. It becomes roughly 2.25 million kilometers in a single hour. That is the whole neighborhood of galaxies, moving as one. Notice that this direction is not the same as the Sun's. The Sun drifts toward the constellation Leo against that ancient light. The local group as a whole leans somewhere else entirely. When astronomers strip away the Sun's long circle around the galactic center, what remains is the bulk motion of the galaxies themselves. And that motion points toward the southern sky. It aims into the direction of the constellation Centaurus. The Sun's private path and the galaxy's deeper flow are simply two different arrows pointing two different ways. So a natural question follows. Why is the whole local group falling in that particular direction? Something must be pulling it, and for decades, astronomers have given that something a plain and honest name. They call it the Great Attractor. It is not a single object you could photograph. It is a vast concentration of mass, spread across a region of space, tugging on everything nearby. It sits somewhere between 150 and 250 million light years away in the direction of Centaurus, and its gravity appears to be steering our entire corner of the universe. The Great Attractor is difficult to study, and the reason is almost unfair. It lies behind the crowded plane of our own galaxy. When we look toward it, we look straight through the thick band of Milky Way stars, dust and gas. That band blocks much of the view. Astronomers have long called this obscured region the zone of avoidance, because the light we most want to see is hidden behind the light closest to home. To map what pulls us, we must peer through the very thing we are riding on. For a time, the Great Attractor seemed like the end of the story. It was the mass that explained the motion. But the picture kept deepening as instruments improved. When astronomers looked farther, past the great attractor and along the same line of flow, they found something even larger waiting behind it. Far beyond Centaurus lies an immense collection of galaxies known as the Shapley supercluster. It holds far more mass than the great attractor alone, and current research suggests that our local group may not be falling into the great attractor at all. It may be flowing past it, drawn onward toward the deeper gravity of Shapley. Sit with that for a moment. The thing we thought was pulling us may be only a waypoint, a landmark we are passing on a longer journey. The true destination could be a mass so distant that its light left before there were eyes on Earth to receive it. We are being drawn toward a place we cannot clearly see, by a gravity that has been acting on us the entire time, quietly, without a single sensation to warn us. This is where the scale of things begins to change character. Until now, each layer of motion has been a circle or a spin. The Earth turns. The Earth orbits. The Sun orbits. Those are loops, patient and repeating. But this deepest flow is not a loop. It is a fall. A slow, immense, one-directional drift toward mass we did not choose and cannot resist. And to understand where that fall belongs, we have to draw the largest map humans have ever attempted. For most of history, we describe the universe in small pieces. A galaxy here, a cluster of galaxies there. We did not know how those pieces fit together, or whether they formed any larger shape at all. That changed only in the last generation. In September of 2014, a team of astronomers published a new way of drawing the map. Instead of measuring where galaxies are, they measured how galaxies move. They traced the flows. They followed the currents of motion across hundreds of millions of light years, watching which way each galaxy was being pulled. And when they drew those flows as lines, a structure appeared. The lines behaved like water on a landscape. In some regions, galaxies streamed together, converging toward a common low point, the way rain gathers into a single valley. The team defined a supercluster not by a hard edge, but by that shared flow. Every galaxy whose motion drains toward the same basin belongs to the same structure, and by that definition, the Milky Way sits inside something enormous. They named it Laniatea. The word is Hawaiian. It means immense heaven, and it was chosen to honor the Polynesian navigators who crossed the widest ocean on Earth by reading the stars. The name fits the thing it describes. Laniatea contains roughly 100,000 galaxies. It stretches across something like 400 million light years. Its total mass is staggering, on the order of 100 quadrillion suns. Our galaxy, with all its stars and all its worlds, is a single small tributary near the outer edge of this vast basin of flow. The four astronomers who defined it were Brent Tully, Helene Courtois, Yehuda Hoffman, and Daniel Pomered. Their achievement was not to discover new galaxies. It was to reveal an order that had always been present and never seen. They gave our address in the universe a shape. We live in the local group. The local group flows within Laniatea. and the great attractor, the mass that steers us, sits near the bottom of the Laniatea Basin, the low point toward which so much of this immense heaven is drawn. It would be comforting to stop here, to say that we have found the edge, the container, the final home, but honesty asks for one more turn, and it is a humbling one. Even Laniatea may not hold. Follow-up studies of that immense structure suggest it might not be gravitationally bound. Its galaxies flow together now, but flowing together is not the same as belonging together forever. A truly bound structure stays whole across cosmic time. Laniatea may only be passing through a shared moment of motion. The reason is the same force that shapes the largest scales of everything. Space itself is expanding, and that expansion is speeding up. Astronomers attribute the acceleration to what they call dark energy, a pressure woven into the fabric of space that pushes distant things apart. Over immense spans of time, that outward push can win against gravity, and if it does, the currents that now define Laniatea could be pulled apart. The immense heaven may be a supercluster that never quite finished forming, already beginning to come undone. So the map we just drew is not a wall. It is a snapshot of a flow that is still being decided. We are riding a current toward a basin that may not survive, steered by a mass that may only be a waypoint, inside a structure that may already be dissolving. And every part of that description is real. Every part of it is measured. None of it produces the faintest sensation in your body as it happens. That returns us gently to the strangest part of the whole account. We have now climbed through every layer we can name. The spin beneath your feet, the orbit around the sun, the long circle around the galactic center, the sun's quiet drift toward Hercules, the fall of the whole galaxy toward Centaurus, and the deeper mass beyond. Each layer is faster than the one before it. Each is measured against a different thing, and not one of them can be felt. This is not an accident of biology, as if better nerves would let you sense it. It is a fact about the universe itself. There is no fixed post in space to measure motion against. There is no wall the cosmos is nailed to. Every speed we have named is a relationship, not an absolute. The equator's speed is measured against the Earth's own center. The orbital speed is measured against the Sun. The galactic speed is measured against the center of the Milky Way. And the deepest speed of all is measured against the ancient light of the early universe. Change the thing you measure against, and the number changes with it. This is why scientists are careful never to fold these speeds into one grand total. You cannot simply add the spin to the orbit to the galactic sweep and announce a single true velocity. The arrows point in different directions. They shift against one another constantly as the Earth turns and the seasons pass. A sum of them would be a fiction, a number that describes no real frame at all. The closest thing we have to a universal speedometer is that oldest light, the faint uniform glow left over from the birth of the cosmos. Because it fills all of space evenly, our motion through it can be read like a subtle tilt. That is why the reading against that glow is the one astronomers trust as the widest and calmest ruler we own. It does not give us a resting place. It gives us a shared background, the one surface against which nearly everything can be compared. And even that ruler only tells us how we drift relative to a glow. It does not reveal a final stillness, because there is no final stillness to reveal. The universe offers no chair to sit in, no ground that is truly still. It offers only motion described in relation to other motion, all the way down and all the way out. Consider what that faint tilt actually looks like when astronomers measure it. The ancient glow is almost perfectly even across the whole sky. Its temperature sits only a few degrees above the coldest cold that can exist. Yet it is not flawless. On one side of the sky, the glow reads very slightly warmer. On the exact opposite side, it reads very slightly cooler. That gentle imbalance is not a wrinkle in the light itself. It is the fingerprint of our own motion pressed onto the background. The reason is simple once you picture it. When you move toward a source of light, its waves crowd together and shift toward the blue. When you move away, the waves stretch and shift toward the red. We are doing both at once to the same sky. The direction we travel toward glows a touch warmer. The direction we leave behind glows a touch cooler. So the oldest light in existence quietly tells us which way we are going. It draws an arrow across the heavens, and the arrow points ahead of us. Read carefully. That arrow gives our sun a speed of about 370 kilometers each second against the background. That is a little more than 369 kilometers with every tick of a clock. It is a far larger number than our march around the galactic center, and it points somewhere else entirely. The warm pole of the sky, the direction we are truly falling toward, lies within the constellation Leo. So while the sun circles the galaxy in one long patient loop, the whole arrangement is also sliding toward the lion, measured against the afterglow of the beginning. It helps to hold these two motions apart in the mind. One is the sun's orbit inside the Milky Way, the steady 220 to 240 kilometers each second around a distant center. The other is this larger drift against the ancient light, the 370 kilometers each second toward Leo. They are not the same journey. The second already contains the first, folded inside a grander motion that the galaxy itself is making. To find that grander motion, we have to stop asking how the sun moves and start asking how the entire Milky Way moves. And the Milky Way moves faster than any of us. Peel the sun's own path out of the measurement, and what remains is the speed of our whole galaxy through the background sea. That figure is larger still. Our galaxy, carrying every star we have ever named, is traveling at roughly 600 kilometers each second relative to the ancient glow. A dedicated space mission built to map that background radiation refined the number to about 627 kilometers each second, with only a small margin of doubt on either side. In the units of a highway sign, that is more than 2 million kilometers in a single hour. Take a moment to let that scale settle without alarm. Every star in the night sky belongs to our galaxy, and the galaxy is not sitting quietly among its neighbors. It is streaming through space at a pace that would cross the distance from the Earth to the Moon in around 10 minutes. The stars appear fixed to us only because they travel alongside us, sharing the same enormous current. We do not feel the current for the same reason a passenger feels nothing on a smooth flight. Everything around us moves together, so nothing nearby seems to move at all. The natural question is where all this motion is aimed. The background light answers that too. The direction of our galaxy's rush is not toward Leo, where the sun alone was heading. It points instead into the southern sky, toward the sprawling constellation of Centaurus. Something in that direction is pulling on us, and it has been pulling for a very long time. For decades, astronomers could measure the tug clearly while struggling to see the thing that caused it. They gave the hidden pull a plain and honest name. They called it the Great Attractor. The Great Attractor is not a single object you could point to like a star. It is a vast concentration of mass, an unusually crowded region of galaxies and dark matter, lying somewhere between 150 and 250 million light years away. Its gravity reaches across that immense gulf and draws our entire neighborhood toward it. For a while it seemed to be the destination, the great weight at the bottom of the slope down which the Milky Way was sliding. But part of the reason it stayed hidden so long is almost poetic. It sits close to the flat, crowded band of our own galaxy, the region astronomers call the zone of avoidance, where the dust and stars of the Milky Way block the view beyond. We were being pulled towards something our own home partly hid from us. As telescopes improved, the story grew stranger and larger. The Great Attractor turned out to be real, but it was not the whole answer. Behind it, much farther out, lies an even greater assembly of galaxies, far more massive than the Great Attractor itself. It is called the Shapely Supercluster, and the newer picture suggests that our local group is not simply falling into the Great Attractor and stopping there. We may be flowing past it, drawn onward toward that heavier prize in the distance. The Great Attractor, once thought to be the destination, begins to look more like a way station on a much longer fall. This is worth pausing on, because it reveals how our sense of the journey keeps deepening. First we measured the spin beneath our feet, then the orbit around the sun, then the sun's long loop around the galaxy, then the galaxy's rush against the ancient light, and now, at the far edge of what we can measure, we find that even that rush has a cause and a direction shaped by structures so large they took generations to detect. Each answer we reached only opened a wider question. The speed was never the mystery. The mystery was always what lay beyond the next horizon. Pulling. To describe that pull honestly, astronomers needed a bigger map than any drawn before. They needed to trace not just where galaxies sit, but where they are flowing, to follow the currents of motion across hundreds of millions of light years and see where they converge. When they did this, they discovered that our Milky Way is not a lonely traveller, and not merely a member of a small local cluster. It belongs to a single enormous structure, defined by the way everything within it streams toward a common region. The map of those flows revealed a supercluster far larger than anyone had charted, and our galaxy lies out near one of its distant edges. The scientists who assembled that map gave the structure a name meant to match its scale. They chose a word from the language of Hawaii. They called it Laniatea, which means immense heaven, a phrase that also honors the Polynesian navigators who once read the open ocean by the stars. It is a fitting name for the largest home address humans had ever written for themselves, and the size behind the name is difficult to hold in the mind. Laniatea contains something on the order of 100,000 galaxies. It stretches across roughly 400 million light years. Its total mass reaches toward a figure so large it barely means anything in ordinary words. Something near 100 quadrillion times the mass of our Sun. Every motion we have traced so far unfolds inside that single vast basin. The Earth spins. The Earth circles the Sun. The Sun circles the galaxy. The galaxy streams towards Centaurus. And all of it flows within the great watershed of Laniatea, drawn along by the combined gravity of 100,000 galaxies and the dark mass woven between them. When you sit still tonight, you are riding not one current but many, each nested inside a larger one, from the turning of the ground to the flow of a supercluster 400 million light years wide. It would be easy to imagine that Laniatea is the final frame, the great still shore where all this motion at last belongs. But the evidence resists even that comfort. Laniatea is not a solid, settled object with firm walls. It is defined by patterns of flow, by the tendency of its galaxies to drift toward a common center. Whether that vast structure is truly bound together, held for all time by its own gravity, is far from certain. The current picture leaves that question open, and there are reasons to doubt a lasting bond. The reason is the same quiet force reshaping the whole universe. Space itself is expanding, and that expansion is speeding up, driven by something we can measure but cannot yet explain, which we call dark energy. On the largest scales, that accelerating stretch works against gravity. It pulls distant things apart faster than their mutual attraction can hold them together, and so the immense heaven that gave us our grandest address may not be a permanent home at all. Some studies suggest that Laniatea could, over unimaginable stretches of time, be drawn apart, its galaxies carried away from one another by the swelling of space. That is the strange shape of what we have found. The closer we look, the larger the motion becomes, and the less solid the ground beneath it turns out to be. We wanted a resting place and kept finding another current. We wanted a boundary and found a structure that may itself dissolve. Yet none of this should feel like loss. It is only the honest reach of measurement, following the arrow the ancient light drew for us, from the warmth of one horizon to the cool of another, out past Leo and Centaurus, past the Great Attractor and the Shapley supercluster, into the immense heaven and toward whatever question waits beyond its uncertain edge. And here is the quietest strangeness in all of it. You are moving through space in at least 4 separate ways at once. You feel none of them. Nothing presses against you. No wind crosses your skin. The floor does not tilt beneath your feet. By every ordinary sense, you are perfectly still. yet the measurements are real, and they never stop. Consider what your body is doing at this exact moment. If you sit near the equator, the ground carries you eastward at about 1,670 kilometers per hour. That alone is faster than most aircraft ever fly. At the same time, the whole planet sweeps around the sun near 30 kilometers every second. The sun then carries you around the galaxy at something close to 230 kilometers per second, and the galaxy itself drifts against the ancient light of the Big Bang at roughly 600 kilometers per second. Layer upon layer of motion, none of it felt. Why does none of this reach you? The answer is one of the oldest lessons in physics. Steady motion by itself produces no sensation. You feel only a change in motion. You feel the push when a car speeds up. You feel the lurch of a turn. You feel the drop when the ground falls away beneath you. But you do not feel plain, smooth speed at all. Picture a calm flight held at a steady height. The aircraft moves fast and level, and a cup of water on the tray stays perfectly still. You could pour a drink without spilling. Only turbulence, only change, reveals that you are moving. The earth beneath you is that steady aircraft, endless and smooth. Its great turns are so vast and so gentle that no cup ever tips. That is why the spin, the orbit, and the galactic rush all hide from your senses at once. There is a deeper reason the numbers refuse to settle into one figure. Every one of those speeds is measured against a different thing. The spin is measured against the center of the Earth. The orbit is measured against the Sun. The galactic rush is measured against the center of the Milky Way. The last and largest figure is measured against the faint afterglow of the Big Bang. 4 speeds, 4 separate anchors. No single ruler joins them together. This is why scientists refuse to add the numbers into one grand total. It is a tempting thing to do. You might want to stack the spin, the orbit, and the galactic motion into a single enormous speed, but that sum would mean nothing. Each speed points in its own direction, and those directions are always shifting. The spin carries you toward the east. The orbit pulls you along a curve that bends every hour. The galactic motion sweeps toward a target far across the sky. Adding them together would be like a passenger walking forward inside a moving train. Their speed along the aisle and the speed of the train belong to different frames. You cannot simply pour one into the other and call the result the truth. The frames do not answer to one another. Each is a separate accounting of motion, kept in its own private ledger, and the directions never hold still. Half a year from now, Earth will sit on the far side of its orbit, moving the opposite way around the Sun. The galactic turn will have carried the whole system further along its curve. What points one way today will point another way tomorrow. There is no fixed arrow set into the sky to measure against. There is no outer wall of the universe to press a ruler against and read off a final speed. This is the meaning of having no absolute reference frame. There is no privileged place that stands truly and completely still. There is no single point from which all motion can be judged as real. with everything else declared to be the thing that moves. Every measurement of speed is a comparison. It only ever answers one question. Moving compared to what? So when someone asks how fast you are truly moving right now, the honest reply is another question in return. Moving relative to what? Relative to the ground under your chair, you may be nearly still. Relative to the sun, you race. Relative to the center of the galaxy, you race far faster. Relative to the oldest light in all of existence, faster still. Each of those answers is correct. Not one of them is more true than the others. They simply belong to different measurements, and yet one answer does come closest to a universal number. It is the speed measured against that ancient light, the cosmic microwave background. That faint glow fills nearly all of space evenly, in every direction you could look. It is not fixed to any planet. It is not fixed to any star or any single galaxy. It belongs to the whole observable universe at once. So a speed measured against it is as close as we can come to a speed measured against everything there is. It is not a perfect place of rest. Nothing in the universe offers that. But it is the nearest thing we have to a still point. And against it, the readings are clear. The sun and its planets move toward the constellation Leo at about 370 kilometers per second. The Milky Way and its neighbors move toward Centaurus even faster, near 600 kilometers per second. Those are the figures that come closest to answering the question the title first asked. Not four scattered speeds, but a single motion of everything you belong to, measured against the light that fills the sky. There is something humbling in accepting this. For most of human history, people assumed the ground was the still and solid thing. The earth was the fixed stage, and the heavens moved around it. It took centuries of careful work to reverse that picture. First the earth began to spin, then it began to orbit. Then the sun itself was set in motion around the galaxy. And finally, the galaxy was found to be racing too. At each step, the resting place we thought we stood upon turned out to be moving. The pattern never broke. Every anchor we reached for proved to be drifting against a larger one. The floor was moving. The sun was moving. The galaxy was moving. And the frame of the ancient light is not truly at rest either. Only the widest stillness we have yet been able to define. So the search for a place that does not move has quietly become one of the great lessons of astronomy. There may be no such place at all. This does not make the numbers less real. It makes them more careful. When a scientist states a speed, a good one always states the anchor beside it. 230 kilometers per second, they say, around the center of the galaxy. 370 kilometers per second, they say, relative to the background light. The anchor is not a footnote. The anchor is half the fact. A speed without its reference frame is a sentence with the subject missing. And so you sit, apparently motionless, holding all of these motions inside a single body. You spin with the planet. You fall endlessly around the sun. You are carried around the wheel of the galaxy. You are swept, with 100,000 galaxies for company, toward a crowded region of the distant sky. Every one of these is happening to you at this instant. Every one is invisible. Every one is measured against a different drifting anchor. There is no contradiction in that. It is simply what it means to exist inside a universe that offers no fixed ground. The stillness you feel is not an illusion in the ordinary sense. Your senses are reporting exactly what they are built to report. They register change, and there is no sudden change to register. The motion is smooth, and smoothness is silence to the body. What the senses cannot do is stand outside the whole system and watch it move. Only measurement can do that. Only the patient comparison of light and time and position reveals the currents you are riding all along. Consider what that patient comparison actually looks like. The oldest light in existence surrounds us on every side. It is the cosmic microwave background, the faint afterglow left behind when the young universe first cooled and turned clear. That light has travelled for nearly the entire age of the cosmos to reach us. It arrives from every direction at once, and it arrives almost perfectly evenly. Almost. When astronomers map it with enough care, a subtle pattern emerges. One half of the sky glows very slightly warmer. The opposite half glows very slightly cooler. That gentle imbalance is not a flaw in the ancient light. It is the quiet signature of our own motion, printed across the whole sky. The reason is easier to feel than to prove. When you move toward a source of light, its waves crowd together and shift toward the blue. When you move away from it, the waves stretch and shift toward the red. The entire solar system is doing exactly this against the primordial glow. The direction we rush toward appears faintly hotter. The direction we leave behind appears faintly colder. From the precise size of that warm and cool difference, astronomers can read a speed. The sun and everything traveling with it move at roughly 370 kilometers a second relative to that ancient light. The warm pole lies toward the constellation Leo. This is why the afterglow of the Big Bang can serve as a universal speedometer. Every other speed already described is measured against something nearby and moving. The equator turns against the planet's own axis. The Earth falls against the Sun. The Sun wheels against the galactic center. Each anchor is itself in motion, so each number is a comparison between two travelers. The cosmic microwave background is different. It fills all of space and belongs to no single object. Reading our speed against it comes as close as physics allows to asking how fast we move against the universe itself. Even here, the answer is not a fixed absolute. It is simply the most complete frame we have found. And the light reveals more than the sun's private motion. When astronomers correct for the Earth's spin, the Earth's orbit, and the sun's long circuit of the galaxy, a larger drift remains. The Milky Way itself is falling. Our galaxy, together with its small family of neighbors known as the local group, moves at roughly 600 kilometers a second against that ancient light. Careful measurements place the figure near 627 kilometers a second. In more familiar terms, that is over 2 million kilometers every hour. And it has a direction. The whole local group streams toward the constellation Centaurus in the southern sky. For decades, that direction posed a genuine puzzle. Something was pulling an entire community of galaxies across space, and the pull was steady and enormous. Astronomers gave the unseen mass a plain and fitting name. They called it the Great Attractor. It sits somewhere between 150 and 250 million light-years away, hidden in the crowded region toward Centaurus. Part of what makes it hard to study is its position. It lies close to the plane of our own galaxy, behind the dust and stars of the Milky Way's disk. That band of obstruction has long been called the zone of avoidance, because the light of distant galaxies struggles to pass through it. The Great Attractor hides, in a sense, behind our own home. But the story did not end when the Great Attractor was named. As surveys reached deeper and mapped more of the flow, a strange refinement appeared. The Great Attractor may not be the true destination at all. It seems to be a way station rather than a final anchor. Behind it, much farther out, lies a far greater concentration of galaxies called the Shapley supercluster. It holds many times more mass than the Great Attractor region alone. Current research suggests that our local group may be sliding past the Great Attractor and continuing on toward Shapley. The nearer pull was never the whole answer. It was only the first landmark on a much longer fall. Step back once more, and even the Great Attractor and its stream reveal themselves as pieces of something larger. Our galaxy does not simply drift through empty space toward a distant mass. It belongs to a vast structure, a web of galaxies bound and guided by the same currents of gravity. In September of 2014, a team of astronomers gave that structure a name and, for the first time, a map. They traced the motions of thousands of galaxies and asked a simple question: which galaxies are all flowing together, and where does that flow finally turn away towards some other basin? The answer defined a single connected region, and the Milky Way sits well inside it. They called it the Laniakea supercluster. The name is Hawaiian, and it means immense heaven. The astronomers chose it deliberately, as a tribute to the Polynesian navigators who crossed the largest ocean on Earth by reading the sky. It was a fitting gesture for a discovery built entirely on charting motion. The four researchers who defined it were R. Brent Tully, Helene Courtois, Yehuda Hoffman, and Daniel Pomerade. Their method treated superclusters not as clumps of light, but as watersheds of movement. A supercluster, in their definition, is simply the region within which everything is falling the same way. The scale of Laniakea is difficult to hold in the mind. It contains roughly 100,000 galaxies. It stretches across something near 400 million light-years. Its total mass runs to about 100 quadrillion suns. Our entire galaxy, with its hundreds of billions of stars, is a single bright thread within it. The Great Attractor sits near the gravitational floor of this basin, the low point toward which so many galaxies drift. When you ask where all our layered motion is ultimately carrying us, Laniakea is the honest address. It is the largest structure we can call home. And yet, even this immense heaven may not truly hold together. Here the story turns humble again, as good science tends to do. When astronomers named Laniatea, they defined it by present-day flows, by the way galaxies are moving now. That is not the same as saying the structure is bound for all time. Follow-up studies suggest that Laniatea may not be gravitationally bound at all. The universe is expanding, and that expansion is accelerating, driven by the mysterious pressure called dark energy. Over enormous spans of time, that outward push can win. The distant members of Laniatea may not remain a single community. They may be slowly carried apart until the great basin we mapped is no longer one structure, but many scattered fragments drifting beyond each other's reach. So the very frame that seemed to give our motion a final destination is itself uncertain and possibly temporary. We move toward Centaurus. We fall toward the Great Attractor, and perhaps beyond it toward Shapley. We belong to Laniatea, and Laniatea may be dissolving even as it guides us. There is no still point anywhere in this picture. Each anchor we reach for turns out to be moving, or unraveling, or merely the nearest landmark in a deeper flow. This is not a failure of measurement. It is the true shape of the cosmos, seen clearly at last. It helps to remember why none of these motions can simply be added together. Each speed is measured against a different reference, and each reference points a different way. The spin of the equator turns around the planet's axis. The orbital fall carries the whole Earth around the Sun. The galactic circuit sweeps the Sun around a distant center. The cosmic drift moves everything against the ancient light. These directions are not aligned. They tilt across one another at every angle. At one moment, the spin of your part of the Earth might add a little to the orbital motion. 12 hours later, the same spin subtracts from it. The numbers are real, but they live in separate frames, and no single arrow can contain them all. This is exactly why scientists resist naming one grand total speed. To add the figures as if they were arrows pointing the same way would be to invent a number that means nothing. The honest approach is to keep each motion tied to the frame in which it was measured. When a single figure is wanted, the speed against the cosmic microwave background is the closest thing to a universal answer, precisely because that ancient light belongs to no local object. Everything else is a relationship between two travelers, each carrying the other's motion in its own reckoning. There is a quiet lesson buried in this refusal to add. It is the same lesson that runs through the whole history of measuring our place. Every generation of astronomers has reached for a fixed platform to stand on. The steady Earth gave way to the orbiting Earth. The central sun gave way to a sun adrift in a turning galaxy. The lone galaxy gave way to the local group, and the local group to the flow toward Centaurus, and that flow to the vast basin of Laniatea. At each step the supposed anchor began to move. The pattern is not an accident. It is the deepest discovery of all, hiding inside a simple question about speed. For if there truly is no fixed ground, then a strange freedom follows. The absence of an absolute frame is not a gap in our knowledge waiting to be filled. It is a genuine feature of the universe, and it carries consequences that reach far beyond the counting of kilometers. To understand why you cannot feel any of this motion, and why that quiet body of yours is right to feel nothing at all, we have to look more closely at what motion even means when there is nothing at rest to compare it to. Consider what your body is actually built to notice. Your senses are tuned to change, not to steady motion. You feel a car when it lurches forward from a stop. You feel it when it brakes or turns hard into a bend. But when it settles into a smooth and constant cruise, the sensation of speed quietly vanishes. Close your eyes on a calm flight, and stillness returns. The aircraft may be crossing the ground at hundreds of kilometers each hour, yet nothing in you protests. This is the ordinary secret behind the cosmic one. What the body registers is the shove, the tug, the sudden change of pace. It does not register velocity itself. It registers only the difference between one moment of motion and the next. Now hold that idea against the earth beneath you. Its spin is astonishingly steady. Every point on the equator has been sweeping along at about 1,670 kilometers each hour for the whole of your life, without ever speeding up or slowing down in a way you could feel. The orbit around the Sun is smoother still. The great swing from perihelion to aphelion changes our pace by less than 1 kilometer each second, spread across half a year. Even the Sun's long circuit of the galaxy, carrying us at something near 220 to 240 kilometers each second, unfolds so gradually that a single human lifetime is a vanishing sliver of one galactic year. And that year lasts roughly 225 to 230 million of ours. There is no lurch anywhere in this. There is no braking, no sudden turn sharp enough to press against your skin. So your body, honest instrument that it is, reports the truth it was designed to report. It reports no change. It calls that stillness. But there is a second reason for the silence deeper than the smoothness, and it returns us to the puzzle we began with. Every speed we have named in this journey was measured against something. The equator's 1,670 kilometers each hour is measured against the Earth's own turning body. The orbital pace is measured against the Sun. The galactic circuit is measured against the distant center of the Milky Way, and the final, largest figures are measured against the faint afterglow of the Big Bang itself. Each number is real. Each is correct. But each answers a different question, because each rests on a different anchor. And here is the quiet difficulty. Every one of those anchors is also moving. The Earth spins while it orbits. The Sun drifts while the galaxy turns. The galaxy races while the whole vast web of matter flows. There is no single platform that stands still while all the others move around it. This is why scientists are careful to say that these speeds cannot simply be stacked into one grand total. You cannot add the spin to the orbit to the galactic circuit to the flow towards Centaurus and announce a single true velocity for your chair. The motions point in different directions. They change their alignment with one another constantly as the Earth turns and the seasons pass. A number that is meaningful in one frame becomes almost meaningless when carried into another. The layered speeds are not rungs on a ladder you can climb and sum. They are separate answers to separate questions, each true only within its own frame of reference. So ask the obvious thing. Which of them is the real speed? How fast, truly, are you moving through space right now? And the strange honesty of the answer is that the question has no single winner. Relative to the ground beneath your feet, you are essentially at rest. Relative to the center of the Earth, you are turning with the equator or with your own latitude. Relative to the sun, you are hurtling along at tens of thousands of kilometers each hour. Relative to the heart of the galaxy, you are far faster still. There is no hidden master number waiting to overrule the others. Each frame gives its own reading, and physics grants none of them the crown of being absolutely correct. And yet, if you press for the closest thing to a universal answer, there is one reference that stands apart from all the local ones. It is the cosmic microwave background, the cooled light left over from the birth of the universe, spread almost perfectly evenly across the entire sky. It does not belong to the Earth, or the Sun, or the galaxy. It fills all of space at once. Because it surrounds everything and favors no particular place, motion measured against it comes as near to a cosmic speedometer as nature allows. Read against that ancient glow. The sun and its planets sweep along at about 369 to 370 kilometers each second, carrying us toward the constellation Leo. And the Milky Way with its local group of companion galaxies drifts faster yet, near 600 to 627 kilometers each second, aimed towards Centaurus and the great mass that draws it. But even this is not a fixed wall at the edge of the cosmos. The background is not a magic frame of true rest. It is simply the smoothest, most even backdrop we can find, the one thing that looks nearly the same in every direction. Our motion against it shows up as the faintest lopsidedness in that glow. The sky ahead of our travel appears a shade warmer, the sky behind a shade cooler. From that gentle imbalance, that whisper of a temperature difference, astronomers read our speed. It is a measurement drawn not from any nearby landmark, but from the entire observable universe, treated as a single quiet reference. That is why it feels like the nearest thing to an answer, and it is also why it still refuses to be called absolute. Sit with the shape of this for a moment. There is no center of the universe from which all motion can be judged. There is no cosmic milestone marking the one place that does not move. Every anchor we reached for, from the solid earth outward, began to move the instant we leaned on it. This is not a failure of our instruments. It is not a gap that a better telescope will one day close. It appears to be a genuine feature of the world. Motion, it seems, is not a thing an object possesses on its own. It is a relationship between one thing and another. To speak of speed at all, you must first quietly choose what you are measuring against. And in that choosing lies the strange freedom hidden inside this whole question. If no frame is the true one, then your stillness is as valid as your motion. Right now you may honestly say you are not moving at all, and mean the room around you. In the very same breath, You may say you are racing across the galaxy at hundreds of kilometers each second, and mean the light of the early universe. Both statements are true. Neither cancels the other. You are at once perfectly still and impossibly swift. And the difference between those two descriptions is only the difference in what you decided to hold fixed. The universe does not settle the argument for you. It simply offers every frame and asks which you would like to use. This is a gentler thought than it first appears. There is no runaway feeling to it, no vertigo, once you understand what it means. You are not being flung helplessly through a void with no ground beneath you. Rather, the ground you always trusted turns out to be one choice among many, no less real for being one of several. The earth is a fine frame. The sun is a fine frame. The distant afterglow is a fine frame. Each is a different window onto the same calm truth. And the body that feels nothing is not being deceived. It has simply chosen the nearest window, the floor and the walls and the still air of the room, and reported faithfully what it sees through that one. Notice too how naturally this dissolves the fear that a great speed ought to be frightening. We tend to imagine that moving at 600 kilometers each second must feel like a plunge, like the edge of some terrible fall. But speed only becomes a sensation when it changes, and only becomes a danger when something interrupts it. Out here there is nothing to strike, nothing to catch you, no wind of empty space rushing past a face. The earth carries its oceans and its mountains and its sleeping cities along at exactly the same pace as you, so nothing is left behind and nothing presses forward. The whole world travels together as one smooth and silent body, and in travelling together it carries no feeling of travel at all. This is why the fastest journey you will ever take is also the most peaceful. The motion is total, and because it is total, it is invisible. So the counting of kilometers, for all its wonder, was never really the deepest part of this story. The numbers are true, and they are worth knowing. Roughly 1,670 kilometers each hour of spin, roughly 30 kilometers each second of orbit, roughly 240 kilometers each second around the galaxy, roughly 600 kilometers each second against the ancient light. But beneath the numbers lies something quieter and stranger, a lesson the universe keeps folded inside a simple question about speed. It is that there is no still point to measure from, and that this absence is not a loss. It is the very condition that lets everything move at once, without a single body being torn from another. There remains one last thread to follow before we can rest. For if motion is only a relationship, and if even the largest structures we belong to are themselves adrift, then we should ask what, if anything, we truly hold on to as we go. We have climbed outward from the equator to the orbit, from the orbit to the galaxy, from the galaxy to the flow toward Centaurus, and outward again to that immense heaven the navigators would have called Laniatea. Now we turn back inward, to gather what all of this has quietly changed, and to see what steady thing survives when nothing beneath us stands still. Begin with the quiet fact that your body reports nothing at all. You feel no wind from the turning equator. You feel no drag from the long fall around the sun. The galactic year passes without a whisper in the inner ear. This is not a failure of the senses. It is a truth about motion itself. Steady movement makes no impression on the body. What we feel is never speed. What we feel is change. A push as a train leaves the platform. A lean as a car takes a curve. When the change ends, the sensation ends with it. The motion may continue, but the feeling does not. So the stillness you experience is honest, in its own narrow way. Nothing beneath you is accelerating hard enough to notice. The spin holds nearly constant through the day. The orbit curves so gently that no muscle could detect the bend. Every layer we have climbed moves with a smoothness that hides itself. The equator carries you at roughly 1,670 kilometers an hour, and still you sit as though on solid ground. Only the arithmetic reveals the speed. The body never will. But there is a deeper reason the numbers feel unreal, and it is the last thread we promise to follow. Speed is not a thing an object simply owns. Speed is a relationship. To measure it at all, you must choose something to measure against. Ask how fast a sleeper on a train is moving, and the honest answer is another question. Moving compared to what? Compared to the seat, the sleeper is still. Compared to the ground, the sleeper races. Compared to the sun, the ground itself is in flight. There is no single answer, because there is no single anchor. This is why every figure in this journey came attached to a frame. Each speed was measured against a different thing standing in for stillness. The spin was measured against the axis at Earth's core. The orbit was measured against the sun. The sun's long circle was measured against the center of the galaxy, some 26,000 light years away. And the grandest motion of all was measured against the oldest light there is. Change the anchor, and the number changes with it. None of them is wrong. None of them is final. The trouble deepens when the anchors disagree about direction. The spin carries you eastward. The orbit sweeps a different way entirely, tilted against the turning ground. The sun's private drift aims toward the constellation Hercules, near the bright star Vega, at roughly 13.5 kilometers each second. The whole solar system leans toward Leo against the ancient light, at some 370 kilometers a second. The galaxy and its local group fall toward Centaurus faster still. These arrows point across the sky in every direction, and they do not hold fixed. As Earth rounds the Sun, the heading of its orbital motion reverses over the course of a single year. As the Sun rounds the galaxy, its direction swings slowly across some 230 million years. That is why the speeds cannot simply be stacked into one grand total. You cannot add a number pointing east to a number pointing toward Leo and call the sum your true velocity. The arrows would have to agree, and they never do for long. This is the caution scientists repeat whenever the question is asked. There is no one honest figure for how fast you are moving through space. There are only speeds relative to chosen frames. Each is true within its own quiet rules. and yet one frame comes closer than the rest to a shared answer. The cosmic microwave background fills all of space, the same faint glow in every direction, left from the universe's first clear light. Because it surrounds everything and belongs to no one, it offers something like a common backdrop. Read your motion against it, and the number is not tied to a nearby star or a single galaxy. It is measured against the whole observable cosmos at once. That is why the figure against the ancient light is treated as the nearest thing to a universal speed. Not because it is more real than the others, because it is more widely shared. So we return to the question we set out to answer, and find it gently transformed. We asked what steady thing survives when nothing beneath us stands still. The answer is not a place. There is no fixed point in the whole universe where you could plant a flag and declare the motion over. Earth's core is not still. The sun is not still. The center of the galaxy is not still. Even the great supercluster we belong to drifts within a larger flow. What survives is not a location. It is the pattern of the relationships themselves. Consider what stays constant while the numbers shift. The equator always turns faster than the poles, by the same clean rule of the cosine of latitude, whether you measure at dawn or at midnight. A city near 41 degrees north will always trail the equator, moving at about 1,260 kilometers an hour, while the equator races at 1,670. Earth will always speed up near the sun in early January, and slow near its farthest point in July. The galaxy will always pull the sun in a vast and patient circle. These relationships hold even as no single speed is ever the last word, and the relationships reach outward past anything we can stand upon. The local group is falling toward the great attractor that hidden waits some 150 to 250 million light years away in Centaurus. Yet even the great attractor may not be the true destination. The same flow appears to carry us past it, toward the far greater mass of the Shapley supercluster beyond. Our home supercluster, the immense heaven the navigators would have named, may not even hold together. Its 100,000 galaxies may be loosely gathered rather than truly bound, and the slow push of dark energy may one day draw them apart. Here the story opens, rather than closes. For if the largest structure we belong to is uncertain of its own shape, then the map of our motion is still being drawn. There is a strange comfort in this. The speeds are real, but they are also provisional, refined with every better instrument and every larger survey. When astronomers read the faint imbalance in the ancient light, they are measuring our motion against the beginning of everything. When they trace the drift of 200,000 nearby stars, they are pinning down the sun's long circle to a sharper figure. Each result is a small act of navigation. Each turns invisible motion into a number a person can hold, and each leaves room for the next measurement to move the answer again. Notice too how humble the largest numbers make the smallest ones feel. The spin beneath you, once the fastest thing you could imagine, becomes the gentlest layer of all. It is dwarfed by the orbit, The orbit is dwarfed by the Sun's circle around the galaxy. That circle is itself carried along in the flow toward Centaurus. Every speed that seemed enormous is nested inside a larger one that barely notices it. You are not moving at one speed. You are moving at all of them at once, each folded inside the next, like rings within rings, none of them cancelling another, and still the body rests. That is perhaps the quietest wonder in the whole account. The four great motions do not fight for the same muscles or the same senses. They share you without strain, because motion at a steady pace asks nothing of the one who is carried. The equator turns you without a sound. The sun holds you without a jolt. The galaxy sweeps you along a curve so wide that a lifetime is far too short to feel it bend. You could sleep through the entire galactic year and wake to the same untroubled stillness, having travelled a distance no mind can truly picture. So the thread we followed inward has led us back to where we began, though the ground looks different now. The stillness is not a lie, and the speeds are not a lie. They are two honest readings of the same moment, taken against two different backdrops. To feel motionless is to measure yourself against the chair and the floor. To be swept across the cosmos is to measure yourself against the light of the young universe. Both answers are yours to keep. Neither erases the other, and the space between them is exactly where the wonder lives. Think for a moment about what it would take to answer the question with a single final number. You would need a fixed post somewhere in the universe, a marker that everyone everywhere could agree does not move. You could then measure all motion against it and call that reading the truth. But there is no such post. Search the cosmos in every direction, and you will not find one still object to anchor your ruler to. Every star drifts. Every galaxy streams. The very space between them stretches as the universe expands. So the honest answer is not one number. It is a set of readings, each one taken against a backdrop that is itself in motion. This is why the speeds we gathered refuse to fold into a single figure. The spin of the equator is measured against the center of the Earth. The orbital rush is measured against the Sun. The long galactic sweep is measured against the heart of the Milky Way. And the fastest figure of all is measured against the faint afterglow of the young universe. Each answer is true within its own frame. None of them is more real than the others. They simply describe different relationships between you and different things. Scientists are careful on this point, and their caution is worth borrowing. They warn that you cannot stack these speeds on top of one another and read off a grand total. The numbers do not line up along one arrow. They point in directions that keep shifting relative to each other. At 1 hour, the spin of the equator adds to the orbital motion. 12 hours later, as the planet turns, it subtracts from it instead. The sun's private drift leans one way, the galaxy's rush leans another. To add them blindly would be to pretend they all pushed in the same direction. They never do. So the layers do not sum, they interweave. And if any single figure comes closest to a universal speed, it is the one read against the cosmic microwave background. That radiation fills the entire sky. It was set loose when the universe first cooled enough to turn clear, long before there were stars or planets to witness it. It is the oldest light there is. Because it surrounds everything almost evenly, it offers something rare. Not a fixed post exactly, but a shared stage against which motion can be measured from anywhere. When astronomers measure our movement against that ancient glow, they find it very slightly warmer in one direction of the sky, and very slightly cooler in the opposite one. That faint imbalance is not noise, it is the fingerprint of our speed. The warmth ahead is the light we are moving toward, gently crowded together. The coldness behind is the light we are leaving. From that tiny lean in the temperature of the sky, the numbers emerge. The sun, carrying all of us, is traveling toward the constellation Leo at roughly 370 kilometers each second. Then the picture widens once more. The whole Milky Way, together with the local group of galaxies it belongs to, moves faster still against that oldest light. The measurement lands near 600 kilometers each second. One careful reading placed it at 627, with only a small margin of doubt, and it has a direction. The motion points toward the constellation Centaurus. Something in that quarter of the sky has been drawing us onward for a very long time. That something earned a fitting name: the Great Attractor. It is a concentration of mass somewhere between 150 and 250 million light years away, hidden in part behind the crowded band of our own galaxy. For decades it was the leading suspect behind our headlong drift, a great weight in the dark, tugging a whole neighborhood of galaxies toward it. Yet the story did not close there. As the maps grew deeper, astronomers began to suspect that the Great Attractor is not the final destination at all. Beyond it lies something greater: the Shapley supercluster, a far heavier gathering of galaxies. Current research suggests our local group may be sliding past the Great Attractor and falling toward that larger mass beyond it. We may be aimed not at the pull we first found, but at a deeper pull hiding behind it. To hold all of this, we need an address larger than a single galaxy. In the year 2014, a team of astronomers drew one. They traced how thousands of galaxies flow across an immense region of space, following the streams the way a hydrologist follows rivers to a basin. They found that our Milky Way sits inside one vast bowl of gravity, where the flows all lean the same way. They named it Laniatea, a Hawaiian phrase meaning immense heaven. The name was chosen to honor the navigators who once read the stars to cross a great ocean. It seemed only right to borrow their word for the sky that carries us. Laniatea holds on the order of 100,000 galaxies. It spans some 400 million light years. Its mass is measured in the hundreds of quadrillions of suns. And yet even that home is not certain ground. Follow-up studies raise a quiet doubt about it. Laniatea may not be bound together by gravity at all. It may be a pattern in the flow rather than a fixed and lasting structure. If the expansion of the universe keeps accelerating, the outer reaches of Laniatea could one day be carried beyond one another's reach. Dark energy, the name we give to that accelerating stretch, may slowly pull the immense heaven apart. Our supercluster, then, may be less a fortress and more a gathering that time will scatter. We have only just learnt its name, and already we are told it may not hold. There is one more motion left to mention, smaller and more intimate, easy to overlook beside the great ones. Even within the galaxy's broad turn, the sun does not simply follow the crowd of nearby stars in perfect step. It has a private drift of its own, about 13 kilometers each second, aimed toward a point in the constellation Hercules, near the bright star Vega. It is a modest speed set against the others, a gentle personal current beneath the larger tides. Astronomers call the point it heads toward the solar apex. It is the direction the sun is quietly wandering, distinct from the vast circle it rides around the galaxy. Two motions at once, the great orbit and the small drift, both carried without the slightest tremor reaching you. And that returns us once again to the strangest fact in all of this. Not one of these motions can be felt. Not the 13 kilometers each second toward Vega. Not the 220 toward the galactic center. Not the 600 toward Centaurus. The reason is the same reason a passenger in a smooth cabin cannot feel the aircraft's speed. Steady motion, without change, presses on nothing. There is no wall of wind, because the air moves with you. There is no jolt, because nothing is speeding up or slowing down against your body. The only things you ever truly feel are changes. A turn, a push, a stop. Constant speed, however enormous, is silent. This is not a trick of the senses, and it is not a failure in you. It is a deep feature of the universe itself. There is no experiment you could run inside a sealed, smoothly moving room that would reveal how fast that room is traveling. You could drop a coin, pour water, watch a pendulum swing, and every result would look exactly as it does at rest. Motion at a steady pace hides itself completely from anyone moving with it. The world offers you no inner speedometer, because deep down there is no absolute speed for it to read. There is only speed relative to something else you have chosen to compare yourself against. So the question we began with quietly changes its shape. It was never really how fast are you moving. It was always how fast are you moving compared to what. Compared to your chair, you are still. Compared to the center of the earth, you turn with the day. Compared to the sun, you race along an ellipse. Compared to the galactic center, you ride a curve so wide it takes hundreds of millions of years to close. Compared to the oldest light in the sky, you are streaming toward Leo faster than any of it. Each comparison hands back a different number. Every number is honest. And the choice of what to measure against is not written into nature. It is chosen by whoever is asking. That freedom is easy to mistake for confusion, but it is closer to a gift. It means the same still moment holds many truths at once, layered like the pages of a book you can read from either end. The reading against the floor gives you rest. The reading against the ancient light gives you flight. Neither is a mistake. They are two faithful descriptions of one unmoving evening, told from two different vantage points, and the universe is generous enough to let both be true. The stillness is your relationship with the room. The speed is your relationship with the cosmos. You are living inside both at the same time, and always have been. There is even a certain order hidden in the layers, a nesting that runs from the small and near to the vast and old. The turning ground sits inside the sunward orbit. The sunward orbit sits inside the galactic wheel. The galactic wheel sits inside the drift towards Centaurus, and that drift sits inside a flow across Laniatea we are only beginning to chart. Each larger motion carries all the smaller ones along without disturbing them, the way a slow river carries a boat that carries a walking passenger who carries a coin turning in a pocket. Nothing inside notices the greater current. It is felt only when someone steps back far enough to measure it against something older and wider still. Consider what that measuring truly requires. To name any single speed, science must first choose what to hold still. It must pick one thing and call it fixed. The turning of the ground is measured against the stars, which seem to stand steady overhead. The orbit is measured against the sun, which sits near the center of its own small system. The galactic circuit is measured against the crowded heart of the Milky Way, and the greatest speed of all is measured against the oldest light in existence. Each number is honest, yet each number quietly depends on a decision about what counts as motionless. Change the choice, and the figure changes with it. This is why scientists resist adding the speeds into one grand total. The temptation is strong. You have a number for the spin, a number for the orbit, a number for the galactic wheel, and a number for the rush toward the far horizon. It feels natural to stack them into a single towering figure. But the arrows do not point the same way. The equator carries you eastward through the morning. The orbit carries you sideways around the sun. The galactic path sweeps you in yet another direction entirely. These motions are not lined up like runners on a track. They lean and cross and fold against one another. Sometimes two of them briefly agree. More often they pull at angles, and the true combined motion is smaller and stranger than any simple sum. There is a further complication that keeps the arithmetic from ever settling. Every one of these motions is turning. The spin turns you through a full circle each day. The orbit swings you around the sun across a year. The galactic path bends you through a curve, so vast it takes hundreds of millions of years to close. So the direction you are traveling this instant is not the direction you will be traveling in 6 hours. Halfway through the night, the ground has carried you to the far side of its turn, and your rotational motion now points the opposite way. The numbers hold steady, the arrows never do. A single total speed would have to freeze a picture that refuses to stop moving. And yet there is one figure that comes closest to a universal answer. It is the speed measured against the ancient afterglow of the beginning. That light fills all of space and belongs to no galaxy, no star, and no world. It is the nearest thing the cosmos offers to a still background. Against it, the whole solar system drifts at roughly 370 kilometers a second toward the constellation Leo, and the Milky Way itself, carrying every star we can name, sweeps at something close to 600 kilometers a second toward Centaurus. If any number deserves to be called your true speed through the universe, it is this one. Not because the others are wrong, because this one is measured against the widest possible stillness we have ever found. It is worth pausing on how modest that stillness really is. The old light does not sit at the center of anything. It is not a cosmic anchor bolted into place. It simply spreads so evenly across the sky that motion within it can be read cleanly. When the whole solar system moves through it, the light ahead is crowded slightly warmer, and the light behind is stretched slightly cooler. That gentle imbalance is the speedometer. It required instruments in orbit, careful mapping, and years of patient measurement to read it. But once read, it gave humanity something no earlier age possessed. A way to ask how fast we are moving, and to receive an answer that does not depend on which star we happen to be facing. Even this answer, though, is not the end of the ladder. The Milky Way does not travel alone. It moves in company with its neighbors, a small gathering of galaxies bound loosely by gravity. And that whole gathering is being drawn across an enormous distance toward a concentration of mass we still cannot see clearly. For decades this pull was named the Great Attractor, a hidden weight lying somewhere between 150 and 250 million light-years away in the direction of Centaurus. It sits behind the crowded plain of our own galaxy, where dust and stars block the view. So the thing tugging on us has never been observed plainly. It has been felt, inferred, and mapped by its effect rather than its face. The story grew stranger as the mapping improved. The Great Attractor, once thought to be the destination, may be only a waypoint. Newer studies suggest that our little group of galaxies is not settling into it, but flowing past it, carried onward towards something far heavier still. Beyond the attractor lies a much greater assembly of galaxies, a supercluster so massive that its gravity may reach across the intervening space and pull entire regions toward it. If that picture holds, then the 600 kilometers a second we register against the ancient light is not the pull of one hidden mass. It is the sum of a nearer tug and a deeper, older summons from farther away. We are falling toward a weight behind a weight. This is the honest shape of the science. Not a clean final figure, but a nested set of motions, each measured against a chosen stillness, each still being refined. The spin is known with great precision. The orbit is known almost as well. The galactic circuit is pinned down by surveys of hundreds of thousands of stars, and even there the best value shifted from about 220 kilometers a second toward roughly 240 as the measurements sharpened. The motion against the old light is measured but debated at the edges, and the flow toward that hidden mass is the least settled of all. The further out you look, the softer the numbers become, and the more the frontier opens rather than closes. There is something quietly beautiful in that softening. It means the largest questions about our motion are still alive. A young researcher today can still improve the figure for how fast the galaxy is being pulled, and toward what. The map of our cosmic neighborhood is not finished. It is being drawn in our own lifetime, survey by survey, as instruments grow sharper and the hidden regions behind the galactic planes slowly give up their secrets. The speed of everything is not a closed fact in a textbook. It is a working measurement, held with confidence where the evidence is strong and with humility where it is thin. Step back once more, and the layers arrange themselves into a single quiet order. At the smallest scale, the ground turns beneath you at something over 1,000 kilometers an hour, though only at the equator, easing towards stillness as you move toward the poles. Around that turning, the world sweeps the sun at nearly 30 kilometers each second, faster in the cold heart of winter, slower in the warmth of July. Around that orbit, the sun leads its family through the galaxy at more than 200 kilometers a second, one full loop taking well over 200 million years. And around all of it, the galaxy itself streams toward Centaurus at hundreds of kilometers a second, drawn by a mass we are only now learning to name. Notice that none of these motions cancels another. The spin does not slow the orbit. The orbit does not blunt the galactic sweep. The galactic sweep does not resist the great flow toward the hidden weight. They simply stack, each riding inside the next, like circles drawn one within another on an endless page. Your body is enrolled in all of them at once. The coin turning in a pocket, the passenger who carries it, the boat, the river, and the tide that moves the whole valley toward the sea. Every layer is real, every layer is measurable, and every layer leaves you feeling exactly nothing, because you and your chair and the floor and the air share each motion perfectly, moving together as one. That shared motion is the final key to the whole illusion. You feel speed only when something around you refuses to share it. The push of a train comes from the track resisting the wheels. The pull of a turn comes from the road bending your path against your will. But nothing beside you resists the spin of the earth, because the ground carries the same spin. Nothing beside you resists the orbit, because the entire world falls around the sun together. The greater motions leave no evidence in the room precisely because everything in the room obeys them equally. Stillness, in the end, is not the absence of motion. It is the perfect agreement of everything nearby to move as one. And so the evening remains calm. The lamp does not sway. The cup of water does not tremble. The stars appear to hold their places, though they too are streaming through the dark on paths of their own. Beneath all of it, the four great motions continue without pause or sound. The turning ground, the sunward fall, the long galactic wheel, the headlong rush towards Centaurus and whatever lies hidden behind it. None asks your permission. None waits for your attention. They have carried you since before you were born, and they carry you now, gently, precisely, and entirely beyond your feeling. The measured universe and the quiet room are not in conflict. They are the same evening, described from two distances, and both of them are true. It helps at the very end to gather these numbers once more, set them side by side, and their true scale appears. The ground beneath the equator turns at about 1,670 kilometers an hour. Move north or south, and that figure falls away with the latitude. In New York, the same spin carries you closer to 1,260 kilometers an hour. This is the smallest of the motions, and still it outpaces sound. Around the Sun, the Earth travels far faster. Its speed shifts between roughly 29 and 30 kilometers each second. The orbit is not a perfect circle, so the pace never holds steady. At its nearest approach in early January, the Earth reaches nearly 30 and a third kilometers a second. 6 months later, at its farthest point in July, it slows by close to 1 kilometer a second. In more familiar terms, its fastest pace is near 109,000 kilometers an hour. You cross that distance while reading this sentence. The Sun does not hold still to let us circle it. It sweeps around the center of the Milky Way at somewhere between 220 and 240 kilometers each second. The higher figure came from a study in the year 2017. Astronomers used the Gaia and Rave surveys to weigh the motion of more than 200,000 stars. That work placed the Sun about 26,000 light-years from the galactic center. Its orbital speed is near 828,000 kilometers an hour. One full lap takes more than 225 million years. The dinosaurs began and ended within a single galactic turn. There is a smaller motion folded inside that great circle. Relative to the stars in its own neighborhood, the Sun drifts at about 13 kilometers a second. It carries us slowly toward the constellation Hercules, in the direction of the bright star Vega. It is the gentlest of all these speeds, and the most local. Even our nearest stellar companions are quietly falling behind. Beyond all of this, the whole galaxy is falling through the ancient light of the Big Bang. Measured against that faint and even glow, the Sun drifts near 370 kilometers a second toward the constellation Leo. The Milky Way and its neighbors move faster still. Their speed reaches roughly 600 to 627 kilometers each second, aimed toward the constellation Centaurus. In kilometers an hour, that final figure passes 2 million. Now recall the one honest caution that governs every number here. They are not steps on a single ladder. Each belongs to a different frame of reference. The spin is measured against the Earth's own core. The orbit is measured against the Sun. The Great Wheel is measured against the galactic center. The final rush is measured against the oldest light there is. These frames tilt and turn against one another without pause, so the speeds cannot be stacked into one grand total. If any single number deserves to be called our motion, it is the one taken against that ancient light. And that number still points towards something we do not fully understand. The pull toward Centaurus was long credited to the Great Attractor. It is a hidden concentration of mass, roughly 150 to 250 million light-years away. Yet the local group may not be settling into it at all. The evidence suggests we are streaming past it. We are drawn towards something larger and farther still, the immense Shapley supercluster beyond. Our motion, it seems, is aimed at a destination we have barely begun to map. Even our home address remains unsettled. In the year 2014, 4 astronomers traced the currents of nearby galaxies. They drew a fresh boundary around them and gave the structure a name. They called it Laniatea, a Hawaiian word meaning immense heaven. The name honors the navigators who once read the open ocean by the stars. Laniakea gathers around 100,000 galaxies across some 400 million light years. Its mass is roughly 100 quadrillion suns. And yet later work questions whether it is bound together at all. It may be a passing pattern in the flow rather than a lasting whole, one that dark energy could someday pull apart. Hold that scale in mind for a moment. The equator's spin would feel like standing still beside the Earth's rush around the sun. That rush in turn is dwarfed by the sun's long circuit of the galaxy, and even the galaxy's own speed is only a fraction of the flow that carries it towards Centaurus. Each motion nests inside a greater one. Each frame of reference opens onto a wider frame beyond it. There is always a larger current, and always a further shore. So the final picture is not a single speed, but a nested set of them. You are turning with the ground. You are falling around the sun. You are wheeling around the galaxy. You are riding a galaxy that races toward a horizon it cannot see. Every layer is real. Every layer is measured, and not one of them can be felt from the chair where you sit. That is the quiet lesson beneath all these figures. Motion carries no meaning on its own. It exists only between things, only as a relation, only as a difference from something else. There is no fixed post in the cosmos. There is no still center against which a true and final speed could ever be read. The universe offers no floor to stand on. It offers only companions, all of them moving, all of them measured against each other. And this is why the room stays calm while the numbers climb. You share every motion with the walls, the air, the light, and the distant stars framed in your window. Nothing near you is left behind. Nothing pulls ahead. The great velocities pass through you and around you, complete and unbroken, asking nothing at all. So let the numbers rest now, gathered and understood. You are moving faster than any traveler in any story ever told, and you have never once needed to hold on. Far ahead, in the dark towards Centaurus, the long journey continues without a sound, and you are already carried gently along with it.